Hello everyone. So welcome to Code with Vishesh channel, and we are discussing the stack playlist. And in our playlist, our next question is remove k digits. So what does our question says? So for our question says that we have given a string of numbers, and we have given a value of k. K will be any integer, and according to the k, we have to remove k digits from this string, and we will be removing the digits such that the remaining digits that will be remain will make the smallest number possible. Means we will be just removing the digits from the given string itself. We will not change the string, and after that, after returning that string that will be remaining for us after k digit removal, that string should be the smallest number that will be possible. So this is our question, and for this our solution intuition should be like this. Our first target should be to make the number smaller. For making the number smaller, our intuition will be to put those number that are smaller in the front while removing the larger number from our given string. So that's the intuition that we will be following. So for this question, we will be taking a stack and simply putting the elements and just checking is their next element is greater or smaller than them. In case if suppose that we have given 143 1432. So for this our k value is 1. So for this, firstly we will put 1 in our stack, then 4 in our stack, because there is nothing that we can do. For firstly 1 will be put in down, and for second 4 is greater than 1, but it will not affect us. So we will put it down because we don't know the next number. Now next number is 3. While putting the 3 in our stack, we will notice one thing, that 4 is far larger and is on the top of our stack. So 4 is larger so than 3, and we are putting 3 that is smaller. So we will pop the 4 first, and after that we will be returning our value. So this is the basic intuition and a simple example to understand how we will be going to do this question. There will be some edge cases, we will discuss them further. Let's take another example. So here we have example of 1432219. This is our example, and our k value is 3. So we will be putting every digit in the stack and comparing, while putting them we will be comparing them with our previous element, means the element that is on top of our stack. If it is greater than our current element, we will simply just pop our previous element, and then we will put our current element, and k will be k will be do lesson by 1, and we will do until our k reaches to 0. This process will continue. So for 1 we will simply put 1 in our stack. Then for 4 we will put again put our 4 in our stack, and after that 3. So whenever we 3 arise, we will pop out 4 first, and then push 3 in our stack, and k will be decreased by 1. Now k is 2, and now putting element that is 2. So while putting 2, we see that 3 is greater, so we will pop out 3 first, and decrease our k by 1, that will be k equals to 1 now, and push the 2 in our stack. Now pushing next element, that is 2. Now when we are comparing this, so 2 is not greater than 2, and 2 is not smaller than 2. There is not any case, so we will just put 2 in our stack and move forward. After that 1, and when 1 arise, we will pop out 2 first because it is greater than, and our top element will be popped out, and then we will put 1, and then we will put 9. Like this we will do until our traversal goes end. So with 9 our traversal goes end, and all the elements are put in our stack. Now we will be returning them in a form of a string and reversing those string because stack works in leaf order. So we will reverse that string to get our correct and smaller element as answer. So we will return our answer. So this is the approach. Let's discuss about the edge cases. So there will be a edge case when k is less than equals to n. There will be three different edge cases. If k is less than or equals to n, means our k means given value number of time we will popping out. It's that value k is less than or equals to given number. So for the equal case, suppose we have three elements and k value is 3, so all the three elements will be popped out, so we have to return the 0 in our string. We have to remember this case. Now for the next, suppose there is a case where element is like 400100 and 4 got popped out. Now remaining string or our answer is 00100. So for this string 00100, the forward two zeros are invalid and we have to remove them manually. We have to remember this because after reversing the string, the number can be changed and can be a wrong number. So we will remove our front front zeros before reversing, or we can remove them after the reversal, depend on us. And last case is k is given as 3 or k is given any value and we does not reach to any condition where our next element, when we compare our I element with our previous element and previous element is greater. Suppose we have a question 1 2 3 4 5 6 and k value is 3. So we will be putting every element in our stack and none of them will be popped out. So in this case, we have to remove the upper 3 element or upper k elements from our stack and reverse as it is and give the answer. Because they 3 are definitely the largest one. That's why they have not popped out yet. So these are the test cases. Now comes to pseudocode. We have given a function in which string is passed and we will be taking a character stack and run the loop from 0 to n minus 1 where we will be comparing is our stack empty. If it is not empty and k is greater than 0 means we have k that we can pop out some element. So k is greater than 0 and stack's top element is greater than our current element. If it is the condition, we will just pop out stack top element and decrease k by 1 and after this our loop gets end while loops ends here and if it is not the condition simply push element in our stack and after this now checking the edge cases for if k is greater than 0 we will just pop out the element if while k is greater than 0. Suppose that all the conditions are happened and k does not encounter, so we will just pop out all the elements that are possible we will be there. So stacks we will pop out those elements and decrease k minus minus, and if stack is empty return 0. That's the edge case. And now take a res means take a extra backend string and compare while stack is empty. Until the stack is not empty, just put all the elements res plus stacks dot top element and after that reverse the res. And for reversing we have to check the conditions like the tracing zeros which are coming forward, we have to compare them also. So while our res is not equals to 0 and res back is not equals to 0 means our res element is not 0. There are some numbers and res back element because the elements that are back on the res string they are the extra 0. If they are 0, that is the condition, so we will be just pop back means res all those 0 will be popped out and after this reverse the string and if reverse string is empty return 0. If it is not, just return number res. So that's how we will able to do this question. Coming upon the time complexity and space complexity, its time complexity will be big O of 3n plus big O of k. K for the k time comparing while loop, and big O of 3n because first traversal is 0 to n minus 1, and second traversal while putting res, and third traversal is while reversing the string. So big O of 3n plus big O of k, and our stack's extra space complexity will be big O n plus big O of n, means big O of 2n. So we are taking extra steps for stack as well as for the res string. So that's how this question gets solved, and we are now up to the end of our stack journey. Soon we will be just closing this journey, and along with that we will be practicing 10 days continuous stack questions to master the style and move further. So we will be revising these concepts again and again to master it, and until that, stay tuned, stay